Hello, Java programmers. We are going to take a deeper dive into writing some code using methods with parameters and return values. We're going to talk about scope of a variable and incremental design. The reason that we want to program with methods is we want to make our code more readable, make it easier to edit, make the code portable, and to divide tasks. And so those are the advantages that we're going to be trying to work on. The simulation that we are running through was a previous program. If I run our previous demo, Module 7 demo, which generated the CAN drive data here, we were simulating how many CAN drives are there. So we're going to input the number of CAN drives, and then we are going to collect the number of cans for each drive. So our input's going to be number of CAN drives. We're going to process each drive, and then we're going to get a total for all of the CAN drives, and that's going to be part of our output. So having that thought in mind, I'm going to come back to my main program here, and we are going to start to think about how we would create each of those methods and incrementally design each one. So when I create my programs, I like to have a little user-friendly message that is just the start message that is going to tell the user, hey, this is what the program's going to do. The program will count the number of cans collected throughout the year. And so I always have or use a start message there. Now, when you are designing your programs, it's easy to get lost. And so I strongly recommend do one method, test it, and then do the next method. So if I run this code so far, Module 7 demo with methods, it is only calling the start message, and my start message runs successfully. The next thing that I need to do in my program is to figure out how many CAN drives we are going to have. And so I need to then create a method for the number of CAN drives. You can see from some of my notes here, if you have started using methods, that I've started to name that method already. So my number of CAN drives, that's going to be my next method that I'm going to work with. Number of CAN drives is going to be assigned the value that is returned from my method. So what would be a good method name? I'm going to call it how many CAN drives, because that's what it's finding out. I also need to send it the resources that it needs, because I want the user to input. I need to send the scanner to that method. So my next part of my program is going to return the number of CAN drives, and I want to incrementally test this. To test to see if that works, I'm going to need to print out that value. This is what I call an echo check. And basically, I'm going to write this method, how many CAN drives. It's going to use the scanner. That's my input to the method. It's going to return a value. It's going to store it in number of CAN drives. And then I'm going to print it out just to see if it works. I have a method stub already created. So if we go to how many CAN drives, my method already generated here because I already did this. So a couple of things. I'm going a little bit fast, so let me slow down and take some time to actually look at this very first line of this method. The very first line of a method is called the method header, and the method header is very important. The method header tells you the return type, it tells you the name of the method, and it tells you what your inputs are, and the inputs are your parameters. So it tells you your input parameters. It's very important. Those input parameters are always going to be inside the parentheses after the name of the method. So we have return type, we have name, and we have the input parameters. So you'll see that here. My return type is the integer. The name of my method is how many CAN drives, and it has to match with the call from my method call. And then I have my input parameters. Now, the difference between the method call on line 17 and my method header on line 28, there's not much difference, but the difference here is when you send the scanner, you don't include the data type. When you send the argument, when you call the method, you don't include the data type or the resource. But when you accept it as a parameter, you have to tell it scanner. That's a scanner object, and we're going to name it input. You have to do that because this method is a standalone method, and it needs all the resources locally in order to perform this job. So please also note, when I sent the scanner, it was named SCNR. I created a new scanner object and it's named input. I have to use input for my in.nextInt in this method. So my scanner object in main is named SCNR for scanner. I send it to my method. It comes into my method and gets passed to the parameter named input. Now when I run this method, it's going to say enter the number of CAN drives. We accept that as an input. We store it to the variable number of drives, and now I need to return number of drives. I need to return that value to main. That value will get stored in this variable in main, and then I'm going to output it temporarily in main to see if it works. So we are incrementally designing one method at a time. My start message worked. Let's see if my number of CAN drives now works. Run the program. I have my start message, and then it says enter number of CAN drives. I'm going to say 3. Press enter. It outputs 3. I just checked my method. So my second method is now written. Now the third method, if I go back up here to main, I'm going to create another method. That method is going to get the total number of cans. So the total cans is going to be assigned the value from the method, and I'm going to call my method get total cans. And then I have to decide what information does that method need. So this is going to be a method that runs a loop that loops through every single CAN drive for the entire year. So it needs to know the number of CAN drives, and I'm going to make it user interactive, so it needs the scanner. So I'm going to create a method. I'm going to send it. We're going to do 3 CAN drives, and then I'm going to ask the user how many cans on drive 1, how many cans on drive 2, how many cans on drive 3. That's what I'm envisioning. Haven't written the method. I have started it. Let's go down and look at that method stub. Here is a little trick that you guys can use. This is my method stub. It's taking in the number of drives, and it's taking in my input for my scanner. It doesn't do anything yet. But if I wanted to test my program, if I want to see if my program is running so far, let's see if it does. If I run my program, it should ask me how many cans I want. Let's try it again. I'm going to run my program. Asks me how many cans. I say 3, and then it prints total cans method, and that's because it went and ran this method, which prints total cans method, before it printed my number of CAN drives. So this is actually correct. But what I'm trying to show you here is this is like a little debugging tool. Like if you know your method's got to return a value, you can just say return 0 for right now, okay? And if you know, you can, I just put in a print statement right here, and actually a lot of programmers will say fix me, meaning that this method has to be written yet, okay? So if I run that code, enter number of CAN drives 3, fix me, total cans method. So basically it's saying, hey, you have to write this method. I know that I have a proper method call. I haven't written my method, but I know that line 18 is working because line 18 went and it called this method, it printed this line, it returned nothing so far because I haven't really written what I want it to return. This is a method stub, and you can stub out your methods to have your code kind of laid out, and then you can go back later and do the coding. Well, let's go ahead and code this method. Okay, we've pasted in some code in order to perform this particular method, so let's take a look at it. I declared two local variables, and that's the cans per drive and then the total cans. And then I have a for loop, and it runs from count 0 through less than number of drives. Number of drives was the value that was sent in. And then I ask the user to enter the number of cans for that can drive, and they will then output, or they will input the number of cans for that can drive using input.nextInt. I store that to cans per drive, and then that variable accumulates. Now what I haven't changed was my return statement. I want to return total cans here. So my return 0 was temporarily in my code in order to stub out this method. Now I have my method written, and now I'm going to return that value to main. To check to see if my output is getting back to main, I can use this output statement, and now I'm going to echo total cans. And when I echo total cans, if I run this code, it's going to ask for how many can drives. We're going to say 3, and then it's going to say, okay, how many cans on drive 1? I'll say 1,200. Second one is 450, and the third one is 400. And then it outputs a number. Like, this is not pretty. This is what I call a naked number. We don't like naked numbers in our code. I also don't like that the output's actually on the next line down. So if I go back into my code, I can use a print statement here instead of a print ln. And that way I'll be able to enter the line, enter the number of cans for that drive on that same line. And I'm just making my output here just a little bit more user-friendly is what I'm doing. So my second method is now, I would say, written. The last method that we have to write then is to output the final results, which I think I'm going to call my print results method. And the print results method, I'm going to send it the number of cans because I want our number of can drives. And I will always tell you, think about how you want this to look on your screen. So I always want it. So what is my output going to look like? I'm going to say something like total cans from, 3 can drives is, blah, 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 XXX. Or if I were to put 999, that just means that it's a number. And so this is what I'm expecting my output to look like. So I need two pieces of data. I need the number of cans drives. I need the number of can drives, and then I need the total cans. And then I'm going to put a semicolon there. And that actually, I don't need to echo check anything there because nothing is being returned. I do need to formulate that output. So I need to go to my print results method. I need to use my two variables that I'm going to send it. I'm going to send it an integer and an integer, and then I'm going to output some user-friendly data. I'm going to bring in number of drives and the total cans. I named those variables a little bit differently than the variables in main. And that's because they are different variables. When a program creates a method, these variables are local to this method. Once this method is done and executed, these variables go out of scope. So now I just need to output my message here that I want. Simple message, total number of cans from blank drives is blank. So we're going to see if that works. We're going to run the code. We're going to have 3 can drives again, and we'll do 1,000, 2,000. You can see how now I'm entering on the same line, and then 3,000. So we have a total of 6,000, and I probably should put cans on the end of that. Well, actually, it's okay. Total number of cans from 3 drives is 6,000. Probably should put a period, though, on the end if I want to make it grammatically correct. And you might not think that's important, but when you actually work with a lot of different languages in communication, it's good to have a proper sentence. So now that's my last method. And I don't know if you've noticed, but I've been opening and collapsing my methods as I use them. This is kind of a nice little trick. Another thing, if you are a beginner programmer, sometimes you could put in a comment that says this is the end of the start message. It would help you kind of keep track of your methods and where things begin and where things end. So you could put in where the end statement here, so then it just knows. So then when you do have your code kind of expanded, it makes it a little bit easier to see where your method begins and where it ends. Another thing that I would mention is that the use of white space, like add white space between your methods. That makes it a little bit more readable, etc. And so this particular program, this video ran way too long, but what we have done in this video is to show you how to modularize your code. We showed you how to pass integer and scanner objects to a method. We used incremental design, and we talked a little bit about scope of a variable, not a lot. I will mention it briefly again. The scope of the variable is the lifetime of the variable in terms of programming language. So in this particular program, we have 4 local variables inside main. They will live for the duration of when main is running. Inside my how many cans drives method, I have a local variable called scanner input, and I also have another variable, number of drives. As soon as this method is done executing, those variables go out of scope, is what we say. So local variables to a method go out of scope when the method is done, is how we say it in programming language, which basically means they no longer exist. Okay? So you might run into some scope issues with your variables, and if you do, please reach out for some assistance. But that hopefully will give you an idea of how you can revise your code. So now if you look at our main program is cleaned up. It's very kind of smart looking versus what the code maybe looked like before, which was something like this. Okay.